Hey everyone, today's lesson from Unit 2 is about the exterior angle theorem. We are going to review the triangle angle sum theorem, and then we'll go on and discuss the relationship between sides and angles in a triangle. Alright, the exterior angle theorem goes like this. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So a little explanation about where each of these angles are in this picture. An exterior angle of a triangle is an angle that's formed by extending one side of the triangle. So angle 4 is our exterior angle. The two remote interior angles are the two angles that are on the other side of the triangle, kind of removed from that exterior angle. So angle 1 and angle 2 are the two remote interior angles. So again, the remote interior angles would be angle 1 and angle 2, right? They are non-adjacent to our exterior angle. Alright, so our theorem again states that any exterior angle is equal to the sum of the measures of the two remote interior angles. Before we go on to practice that exterior angle theorem, we're going to review the triangle angle sum theorem. Alright, so the triangle sum theorem states that the sum of the three angles in a triangle add up to 180 degrees. So I'm just going to write that here. The three interior angles of a triangle add to 180 degrees. And that's always true, no matter how big or how small your triangle is. Okay, very often to prove something, we have to add what's called an auxiliary line. So an auxiliary line is a line added to a diagram to complete a proof. And our auxiliary line in this proof is this line from x to y right here. Okay. This line is going to be set up to be parallel to line AC. And then if you notice, we can use AB as a transversal, and we could also use BC as a transversal. Okay, so in our proof, we're given our triangle, so that's given right there in step 1. Step 2, the instructions for drawing our auxiliary line XY through point B parallel to AC. So we're just going to make a note that we're drawing this as an auxiliary line. Technically, we should put in that through any 2 points there is a line. Okay, next, what we can take away from that is that we've got a series of alternate interior angles that are congruent to each other. So for example, angle 1 down here and angle XBA are alternate interior angles. So they would be congruent. I'm just going to kind of highlight them a little bit. Also, on the other side, we have the measure of angle 3 and the measure of angle YBC that are also alternate interior angles. And again, they're congruent because they're formed by parallel lines. And really, I should have some arrows to indicate that these lines are parallel. Alright, the reason that we'll put into our proof for these lines to be congruent would be the alternate interior angles theorem. Alright, next, if you take a look in your diagram, notice that those three angles, angle XBA plus angle 2 plus angle YBC, are all equal to 180. And we can get there by using the angle addition postulate. Finally, to get to the point where we say all three angles have a sum of 180, we're going to use some substitution. Our first substitution comes in when we take out the measure of angle XBA and replace it with the measure of angle 1. We're going to leave the measure of angle 2 in there. Then next, we'll take out the measure of angle YBC and replace it with the measure of angle 3. So we get that final statement, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 by substitution. Okay, well, I'm never going to have you do that proof for me on a quiz or a test. We just need to take away from that the three interior angles of a triangle add to 180. All right, now for some practice with the exterior angle theorem. So notice in number 4, we're going to solve for x, and x is an exterior angle, so I'm just going to make a note of that. I'm going to abbreviate. And our two remote interior angles will be the 56 and the 47. So our equation will be x is equal to 56 plus 47. So your angle on the outside is equal to the sum of the two remote interior angles. So take and add 56 and 47 to get 103 degrees. And that's it. That's our final answer. Okay, on number 5, we notice that this exterior angle is 90 degrees. So 90 will be equal to the sum of the measures of the two remote interior angles. So this time, our x value is on the other side of the equation. It would be x plus 34 is equal to 90. Take and subtract 34 from both sides, and we end up with 56 degrees. So x equals 56. Right, and our next one, number 6, just be careful here. There's a follow-up question. It says, what is the measure of angle CAB? So we have to actually find this angle measure in the end. So we're going to solve for x first, and then we'll take it and plug it into that equation. Okay, the exterior angle is 91. And that exterior angle has a measure equal to the sum of these two that I've highlighted in blue. So our equation is going to be a little bit longer. We have 91. Set it equal to 8x minus 1 plus 4x plus 8. Take and add your like terms together. So you have 91 is equal to 12x, because I have 8x plus 4x. They're on the same side of the equation, so combine the like terms. And then we want to combine negative 1 plus 8. Negative 1 plus 8 is a positive 7. Okay, get the 12x alone by subtracting 7 from both sides of your equation. 91 minus 7 is 84. So if 84 is equal to 12x, so then take and divide 84 by 12. And 84 divided by 12 gives us 7. Okay, don't forget, there was a follow-up question. So the measure of angle CAB it's represented by 8x minus 1. So now we're going to take and plug 7 into that for x. 8 times 7 is 56. 56 minus 1 is 55 degrees. So this angle right here is 55 degrees, CAB. Okay, number 7, we also have a follow-up question. We have to find the measure of angle H. So we're going to be plugging our number into that for our final answer. Okay, so in this case, our exterior angle is 7x minus 24. So I'm just going to label that for you. So that exterior angle of 7x minus 24 is going to be equal to the sum of the two remote interior angles. So the 3x plus 12 and the 2x are the two remote interior angles. So I might write it as 2x plus 3x plus 12. Might make it a little bit easier to have those x's right next to each other. 2x plus 3x adds to a total of 5x plus 12. Okay, we have variables on both sides. We have constants on both sides. So I would probably move the 5x to the other side by subtracting it first. 7x minus 5x is 2x. Minus 24 equals 12. Take and add 24. Alright, so this goes to 0, and we've got 2x left over. And 12 plus 24 is 36. So if 2x is equal to 36, then that means that x will be equal to 18, because I need to divide by 2 on both sides. Okay, don't forget the follow-up. The measure of angle H is equal to 3 times x plus 12. So we need 3 times 18 plus 12. Don't hesitate to take a little help from your calculator, just for accuracy's sake. 3 times 18 is 54, and 54 plus 12 is 66 degrees. Okay, the problems at the bottom of this page are a little different. They do involve exterior angles, but they also involve the triangle angle sum, and actually even vertical angles will come into play. So in number 1, since the 3 angles of this triangle are all marked congruent to each other, we can find the measure of one of those angles by taking 180 and dividing it by 3 and getting 60. So it would be 60 degrees all around. So one way to find x is to say it's an exterior angle. So its measure would be equal to the sum of the two remote interior angles, these two. X equals 60 plus 60, or x is equal to 120. In this problem, however, it might be quicker just to work with these supplementary angles right here. X and 60 form a linear pair, so you could just take 180 minus 60 and get x equals 120 that way. Right, on number 2, we see that these two angles at the bottom of the triangle are marked congruent. So you might find it helpful to call them each y, and another variable. You should take 180 minus that 44 degrees, and that gives you 136. And then take 136 and divide it by 2, and that gives you 68 degrees. So each of these angles is 68. You could also write the equation y plus 44 equals 180 and solve that. So that would be 2y equals 136, or again y is equal to 68. So to find the measure of x, our exterior angle, we're going to take 44 plus the 68, and we get a total of 112. Okay, on the last two problems, we're going to use the triangle angle sum. And when I think of these, I like to think of them as puzzles. So I often look for a triangle where I know 2 out of the 3 angles. And then I know I can take 180 and subtract the 2 angles that I know, the 43 and the 57, and see what that leaves me with. And what I'm left with is 80 degrees for this angle. Next, using what I know about vertical angles, I can bring that 80 over to the other triangle. And now I can use the triangle angle sum for this triangle. So x plus 80 is equal to 180. That would give us 2x is equal to 100 once I combine like terms and subtract 80 from both sides. And when I divide by 2, I get x equals 50. Alright, and number 4, it's a little trickier. You have to kind of look for triangles where you know 2 out of the 3 angles. I notice this triangle on the right first. I have 53 degrees and 80 degrees. So what I might do is solve for this angle right here first by taking 180 and subtracting 53 and subtracting 80 from it. And we come up with 47. So this angle right here is 47 degrees. Next, I might take a look at this triangle over here and do something similar where I take 180 and subtract the 2 angles that I know, the 62 and the 50. And when I do that, that leaves me with 68 degrees. So this angle is 68. I know it's getting pretty confusing in here, all these triangles. I want to work with this triangle right here. I have 47 and 68. When I subtract those from 180, 180 minus the 68 minus 47, that leaves me with 65 degrees. And that's actually a vertical angle to the angle marked with the x. So x is equal to 65. For the last portion of our lesson, we'll be taking a look at the relationship between sides and angles in a triangle. So there's a direct relationship that exists between the length of a side in a triangle and the measure of the angle opposite it, or across from it. So in our triangle, the first question says, what is the longest side of triangle ABC? Now, it's a little hard to tell without actually measuring in some cases, but in this case you can see that side AB is the longest side. So remember that it's a line segment, so use 2 capital letters and then the symbol for a segment above it. That means that the largest angle is going to be angle C. You see that angle C appears to be a 90-degree angle. We can't assume it, so I'm just going to mark it with an arc. But angle C appears to be the largest angle. And notice how it is opposite the longest side. In our second triangle, it says, which is the shortest side of triangle DEF? Well, it certainly appears that DF is the shortest side. And then the question following says, which is the smallest angle? And I would say angle E appears to be the smallest. So our takeaway from this is that the largest side of a triangle is opposite the longest side. Sorry, the largest side of a triangle is opposite the largest angle. And vice versa, meaning the largest angle is opposite the largest side. The smallest side of a triangle is opposite the smallest angle. In example 1, it says, express the side lengths of triangle GHI in order from least to greatest. Well, first, find the missing angle. To do that, remember that the 3 angles in a triangle add up to 180, so subtract 88, subtract 42 from 180, and we find that that missing angle is 50 degrees. Alright, so next find your smallest angle, which is the 42, and the side opposite 42 degrees is GI. So GI will be the shortest side in our triangle. Next comes the angle of 50 degrees. It's the next largest. And the side opposite 50 is GH. And then finally, we have our 88 degrees at the top. And 88 is the largest angle and is opposite the side marked HI. So 2 capital letters and then a symbol for a segment. In our next example, number 2, it says list the angle measures of triangle JKL in order from largest to smallest. So we want to start with the largest angle, which means we also want to start with the longest side. So JL is the longest side, and its opposite, angle K. So angle K would be the largest angle in that picture. So give the angle symbol and then capital letter K. The next longest side you see in here is the side length KL. It's 15, and its opposite, angle J. So next on our list would be angle J. And then finally, that third side of 8, right here, JK, its opposite, angle L. If it helps, you can also put a little arc in there for your angle symbol. Okay, on the last two, it says which option correctly relates the size of the sides of triangle MNO. And we're going to list them in order from largest. So I'm going to do LG for large, medium, and small. Okay, first, find the missing angle. And we're going to do that by taking 180 and subtracting the two angles that we already know. So 180 minus 63 minus 57 leaves us with 60 degrees. Okay, so now if we want to know the longest side in here, start with the biggest angle, which is 63. And that angle is opposite MO. So MO has to be our longest side, okay? Now that helps us eliminate two of our answer choices. Number 1 has MO or OM in the middle, and so does number 3. So OM has to be at one end or the other. All right, next, go with your angle marked with the 60 degrees. That's the next largest, and its opposite, NM. So NM is going to be our medium length side. And that leaves NO to be the shortest side in here. Okay, so in answer number 2, it says that NO is greater than MN is greater than OM. And that's just not true. NO is smaller than the other two. So that leaves us with the answer being number 4. NO is less than MN, which is less than OM, and that's a true statement. Okay, number 4, it says which option correctly relates the measure of the angles of PQR. Okay, so again, we want to go large, medium, and small. The largest angle is going to be opposite the longest side. So 12 is the longest side, and its opposite, angle Q. So angle Q has to be the biggest. Next, we have the side length of 8 down here, and that's opposite angle R. And that leaves angle P to be the smallest. Okay, so we're looking for angle Q to be the largest, angle P to be the smallest. So that eliminates answer choice 1, where angle Q is in the center, and 4 also has angle Q in the center. Alright, so answer choice 2 says the measure of angle Q is greater than the measure of angle R, which is greater than the measure of angle P. That's a match with our list. Option 3 is not true because angle P is listed in the center there. So eliminate that one. So 2 is the correct choice. Alright, good luck on the practice and the learning check. As always, please make sure you ask if you have questions.